Every computer on Earth, your phone, the servers running the internet, the machines guiding spacecraft, shares one invisible limitation, a limit that was not discovered by accident. It was proved mathematically before any of those machines existed, before anyone had even built a working computer. In 1936, a 24-year-old in Cambridge sat down with a blank sheet of paper and asked a question nobody had thought to ask. Is there a problem that no computer can ever solve? Not a hard problem, not a slow problem, a problem that is simply, permanently, forever impossible. His answer shook mathematics, and then it built the modern world. His name was Alan Turing. He was a mathematics student at Cambridge, quiet but relentless, the kind of person who ran marathons alone and ate an apple every night before bed. He had not yet built anything. He had no circuit boards, no transistors, no machines of any kind. He worked only with ideas. And in 1936, he used those ideas to invent the concept of a computer, entirely on paper, just to answer a question about its limits. If you want to discover how this solitary genius went from a quiet Cambridge student to a legendary wartime codebreaker, we have produced a full, definitive documentary on Alan Turing's extraordinary life. You can watch the complete story right now via the link in the description below. But in 1936, his journey was just beginning. Here is the question Turing was trying to answer. It came from a German mathematician named David Hilbert, who had asked, "Is there a mechanical procedure, a fixed set of steps, that can decide whether any mathematical statement is true or false? Can everything in mathematics be solved by following a recipe?" Turing realized that to answer this, he first needed to define what a machine actually is. So he invented one. In his head. He imagined a machine that reads a strip of tape, one square at a time. Each square has a symbol on it. The machine reads the symbol, checks a set of rules, and decides what to do next. Write a new symbol. Move left or right, or stop. That is all it does. Read, decide, act. Over and over. This imaginary machine, now called a Turing machine, turned out to describe exactly what every real computer does. Your laptop is a Turing machine made of silicon. Now, Turing asked a specific question about this machine. Can you write a program that looks at any other program and decides, in advance, whether that other program will ever finish running, or whether it will loop forever? This is called the halting problem. Will the program halt, or will it run until the heat death of the universe? Turing proved, using nothing but pure logic, that no such program can ever exist. Here is how his proof works, in plain English. Suppose someone claims to have built a program that can predict whether any other program will halt. Call it the decider. Turing then constructs a new program using the decider, a program that does the opposite of whatever the decider predicts. If the decider says the new program will halt, the new program loops forever. If the decider says it will loop forever, the new program halts immediately. Now ask the decider to analyze itself. Whatever it predicts, it is wrong. The decider cannot exist without contradicting itself. The halting problem has no solution. Not now, not ever, not with any machine, no matter how powerful. This was not a flaw in Turing's design. It was a fundamental law of computation. That proof had an extraordinary side effect. In building the argument, Turing had described, precisely and completely, what a computing machine is and what it can do. He had invented the theoretical blueprint for the computer before a single transistor had been manufactured. When engineers began building real computers in the 1940s, Turing's framework was already waiting for them. Every programming language ever written, every operating system, every app on every device runs on the architecture that Turing defined on paper in 1936. The question that could not be answered gave us the machine that answers almost everything else. Alan Turing set out to find the edge of what logic can do, and found it. Which makes you wonder, what other edges are out there, waiting for someone to sit down with a blank page and ask the right question?